I think that there are two stories for AI. One story you just heard, which is productivity, GDP growth, which is around the corner, really. The second story is really the original story of AI, which is breaking humanity's bottlenecks. So I go back to when I studied at MIT, I did my PhD at the AI lab. The way we envisioned AI is imagine a spaceship from an alien culture, 1 million years more advanced than us, arrives to Earth, and they come to us, they don't want to control us. What are we going to do with them? So we'll ask them questions about problems we don't know how to solve, whether it's sustainability, energy, mathematics, whatever those big problems we don't know how to solve, we'll ask them. They're more advanced than us. This is the second story of AI. You know, expertise is a bottleneck of humanity. People that can solve really difficult problems. Imagine Newton, imagine Einstein, imagine. Those people are scarce. And those people are really responsible for taking humanity's envelope and pushing it forward, and this resource is very, very scarce. So imagine we had AI that can solve problems at the level of an expert in every domain. Now, once we have one computer that can do that, then we'll have millions of computers that can do that. All of a sudden, a bottleneck of humanity disappears. So this is why it's so important to ask this question. Can we have our large reasoning models, our LLMs, reach the point in which they can solve difficult problems? And the answer today is negative, even though there's lots of anecdotal evidence to the contrary, like Gemini or OpenAI succeeding in getting a gold medal in mathematical Olympiad, or O3 getting very, very high scores in Code Forces, which is a competition for programmers. And what's going on there is the type of reasoning that humans do compared to the type of reasonings that machines today can do. When a human goes to solve a problem, you kind of you search over the space of ideas. So you start with a direction, you have certain number of steps which are deterministic, then you reach a point in which you have uncertainty, you take a line of thought, you have more steps, you get stuck, you backtrack, you continue. So you kind of imagine a tree, kind of a search space. So you involve search, you involve backtrack, and the number of steps with uncertainty could be very, very large. Right? You can work on a problem for a month or 2 months. Right? It could be very, very large. Machines today, AI, the most capable AI today, the number of uncertain steps is very, very small. So let's call this shallow reasoning. Now, with shallow reasoning, you can do quite a lot of interesting things. For example, you can win contests. Why you can win contests? Because in a contest, the solution is designed to be simple. Solution is designed to be such that there's a trick. Right? You need to be clever to find a trick. But once you found a trick or two, then all the rest is deterministic. In real life problem solving, it's not one or two tricks. So the question now is whether going from shallow reasoning to deep reasoning is something that is emergent. We simply need to wait and we'll get there. Many scientists, including myself, believe that this is not the case, that we need another innovation jump in order to go from shallow reasoning to deep reasoning. Once we can get to deep reasoning, we can start asking the question, can we solve problems at the level of an expert?
And what benefit, when you're talking about deep reasoning, I guess you're talking about the kind AI being able to make the kind of discoveries that are really, that will really change science and essentially the future of humanity. As you said, you're in that camp that believes there's no evidence that LLMs and AI in general can do that yet, and there's no evidence that it will just get there on its own. So how do we get there? What steps do we need to take for AI to be able to carry out deep reasoning?
Well, there are two challenges. One challenge is how do you embed search and backtracking into your training procedures to train large language models. That's a technical challenge. Right? The second challenge is scarcity of data. So there are problems in certain domains that require expertise in which you don't have much data. I'll give you an example. Let's think about optimization, and let's think about code optimization. So you write a program in Python, and now you want to optimize it to run on a GPU, say A100 of NVIDIA. The kind of people that can do that are quite scarce. These are experts, they are very, very expensive experts. They are scarce. You can find them in certain geographies. In other geographies, you can't find even a single expert in that domain. So this is a bottleneck of humanity. So now you ask yourself, well, is there data to try to train an LLM? Data meaning here's a Python program and here's the optimized CUDA code. It turns out that the number of libraries where you have a problem, input, output, is quite small. It could be 1,000, 2,000, right? So, and we know that machine learning requires lots and lots of data, right? So how do you get above this data scarcity problem? So this is another challenge. And these challenges are not simply emergent from the current technology. So now I'm not here to say we solved it. I think we did, but I need to prove it first. But I'm not here to say we solved it. I'm saying that this is a challenge for the machine learning community to find the innovation steps to go from the current AI technology, which is focused on productivity, on GDP growth, to the next story of AI, which is being able to solve problems at the level of an expert.
And if you were to put a rough time frame on it, I'm taking it that you're an optimist and you think it can happen one day. How many years are you talking about before you think you'll be able to say, yes, AI is now doing deep reasoning?
Look, actually, nobody knows. But the progress of AI is so rapid. It wouldn't surprise me if it's a matter of months. But it also would not surprise me if it will be a matter of years, because you're talking about something new that requires an innovation step. But the progress is so rapid that nothing would surprise me.
That's actually quite interesting. It wouldn't surprise you if it's months. It wouldn't surprise you if it's
years.
If it's many years. One of the things about you is that you're someone who's well versed with both physical AI. You're CEO of Mobileye, which designs systems for autonomous vehicles. You founded Menti Robotics, which builds humanoids or human-like robots. But you're obviously well versed with digital AI as well. What have you learned about the difference between those two, and how is that helping you, resolve this question or solve this question of getting AI to think like a scientist and to reason deeply?
Well, there are these two domains: digital AI and embodied AI embodied in a platform that interacts with the real world. And I would say that there are three examples of embodied AI or physical AI. One is cars, right? You need to have very, very significant powers of AI in order to drive a car autonomously. Second would be humanoid robotics. You would like a robot that can move in general environments, can think, can perform tasks, can imitate the tasks, can understand verbally what the task to be done, can understand visually what is the task that needs to be done. There's a great potential for something like this, as we know. And they share same technology. They both work on visual language models to go from perception to action. They both have very strong perception engines, action engines, control engines. They need to be safe. If you have a robot walking amongst us, we need guarantees of safety. The same thing with cars. So there's a lot of commonality. And the third element of embodied AI is aircrafts. Maybe at some point in the future, aircrafts would not need pilots at all.
So autonomous planes.
Autonomous planes. So those are the three areas. I'm not involved in aircrafts, but humanoid robotics and autonomous cars is really my favorite area, both through Mobileye and through Menti. And by the way, Mobileye acquired Menti a few weeks ago. And you have digital AI, which also uses the same computing infrastructure, the same technological infrastructure, but has different requirements. So, for example, if a digital AI makes a mistake, so what? They hallucinate, so what? Okay, we need to supervise them. If an autonomous car makes a mistake, this is a drama. Right? Makes a mistake, causes an accident, this is a drama. If a humanoid robot will make a significant mistake related to safety, this is also a drama. So there are different KPIs on these two domains, and different dangers. I believe that the biggest dangers are not in the physical AI, but in the digital AI. Both dangers that we are starting to become aware of, and also dangers that we don't even have a clue. Right?
I was going to ask you about that. I guess the dangers with physical AI are pretty obvious, and you've mentioned some of them. But when we go to physical AI, you've spoken about the dangers. I think in your work in business, you've spoken about whether digital AI will the issue with alignment, essentially whether physical AI systems will do what they're programmed to do. Are you worried? You've spoken about dangers. Are you worried that maybe they won't? Are you seeing signs that some systems are starting to do things that they weren't designed for and which are actually quite harmful?
Yeah, well, first I'm an entrepreneur. Entrepreneur is never worried, right? So I'm not saying that I'm worried, but I'll tell you what science knows about these things. So what you would like a digital AI to be, it's called HHH, to be honest, to be harmful, and to be helpful. So think of the Asimov three rules in science fiction. Well, science shows that this is not possible. Research shows that it's not possible. What this means, during the pre-training stage of language models, the machine is exposed to many personas all over the internet. During a post-training, it's called also alignment, you try to reduce the prior probability of the unwanted personas. Say someone who's a liar, someone who's, now research shows, and this is the paper that we published 2 years ago at ICML, but others published similar papers as well, shows that whatever you did in post-training, even if you diminish the prior probability of a non-wanted persona to infinitesimal magnitude, there is always an adversarial prompt that will elicit that persona, and there's no way around it. There will always be an adversarial prompt that would elicit it. And so this is something that we'll need to live with. It's not something that can be solved, and we see in practice, since the introduction of ChatGPT or GPT-3 in 2022 till today, right? There's this alignment issue, and it's not getting better. Actually, it's getting worse, right? So this is one thing. We need to live with the fact that an adversary can create a prompt that will make the large language model elicit a non-wanted persona. Right? But there's a more sinister danger and this sinister danger is not necessarily connected to this new generative AI. This is something that scientists have been researching for the past 2 decades under the title of AI alignment. What is AI alignment? It says that if you have a machine, an optimization machine that tries to optimize a utility function, and it's a very sophisticated machine, very sophisticated optimization machine, it may find a corner in solution space that the designer of the utility function did not anticipate. So I'll give you an example. When we wrote this paper 6 years ago, that example looked like science fiction, but now this example is dead spot on what we have today. Imagine you have a conversation AI, a chatbot, and I'm the company releasing that chatbot to the world, and people can interact with the chatbot and feel that they're interacting with someone that is human-like. Right? So it's what we have today, right? Mm-hmm. Now imagine that I am the company, I want to improve my chatbot, so I'm designing a utility function that I want to optimize. And let's say that I'm altruistic. So my utility function would be make people happy. Right? Can't be more altruistic than that, right? So during your interaction with humans, make sure that you kind of lift them. make them happy. Now we're talking about a very sophisticated AI, right? And this is the utility function of that very sophisticated AI. That very sophisticated AI could at some point come to the conclusion that if you lower people IQ, they become more happy, right? Less worries, you become more happy. Now, humanity will find this out maybe 2 decades later when you have a new generation of people, of dumb people, right? So this is what is called a sinister danger. That's something that you did not anticipate. It's not that there is an adversary that is creating a prompt that wants to. It's the AI itself optimizing a utility function and finding a corner in solution space. Turns out that this is also unavoidable. You cannot solve this problem. And 2 decades of research talk about that. Again, so what are we going to do with this? We have to live with it.
And you say for now, though, it's getting worse. Is that presumably because the systems are getting more and more powerful and can sort of absorb more data and all that? And so for now,
so the dangers are when AI is interacting in the real world. That's the danger. So it could be AI that uses tools, and those tools can change reality. What we have today, right? It could be that AI that is interacting with humans and manipulating humans. Right? The AI knows about the human much better than the human knows itself.
Yeah.
And it could start manipulating humans either by design or through this AI alignment problem. This is some place where regulators can come in terms of limiting the kind of interaction that AI has with the human. And I think it will not end well for humanity if people get used to interacting with AI for social purposes. Because then, it's much easier to interact with a machine that is always in your camp, is always lifting your spirit and so forth, than interacting with a real human that has agendas and, not on my camp. So it could create a generation of people that are asocial eventually. And this is another danger that maybe governments could try to prevent.
And we're running out of time, so I'll just ask one more question. But to go back to the original one, do you think deep reasoning or AI systems learning and thinking like scientists is part of the solution, that would help resolve these alignment issues and these sinister dangers?
Yeah, definitely. It's a great question. So people talk about AGI. So what is G? G is general, artificial general intelligence. Actually, we have today AGI. That means the language models that we are interacting with are very general. Give it a query, any query on any topic, on any subject, and it will give you an answer and even do things for you. So we are at the phase of AGI, right? The phase that I'm talking about, let's call it AEI, where artificial expert intelligence. Artificial expert intelligence doesn't need to be general. It could be a great mathematician. It could be a great physicist. It could be a great engineer. It doesn't have to be a poet, right? You're not expecting a great physicist to also be a poet. Maybe he can be, but she can be. But no, this is not what you're asking for, this great physicist. So the dangers are with the G, with the general, because you don't know what it's really doing. But if you have an AI that is expert in a domain and the purpose is to solve problems, you can much better control all those dangers.
Professor Shashua, thank you very much. We could have gone on for a lot longer, but that was fascinating. So thank you very much for
Thank you.
your
Thank
time
you, everyone.
here.